Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the third question whereby I'm only focusing on chemical equilibrium. Please do expect a total number of 8 videos since I've compiled a worksheet that has 8 questions in total. And please note that guys, each and every one of these questions are extracted from past exam question papers. So please do take this seriously guys, because I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your exam. So please do share the video to your peers so that they may have the same edge as well. And please guys, do help us grow the channel by just subscribing. Nah? Okay. Initially, 2.2 grams of pure carbon dioxide is sealed in an empty 5 cubic decimeter container at 900 degrees Celsius. Okay, first question, they want us to calculate the initial concentration of carbon dioxide. We do have an equation that says concentration is equal to mass all over the relative atomic mass multiplied by the volume. The relative atomic mass number, guys, for carbon dioxide, we have 1 carbon plus 2 times oxygens. So the atomic mass, the relative atomic mass number for carbon is 12. And then for oxygen is 16. So 12 plus 2 times 16. This will just give us 44 grams per mole. So this is our relative atomic mass number. All together. So therefore, for us to calculate the mass, the concentration, I'll simply say 2.2 divided by 44 multiplied by the volume of the container. That's 5 cubic decimeters. So this is just 2.2 divided by 44 times 5. I'll simply get 0.01 moles per cubic decimeter. So the initial concentration of our carbon dioxide is 0.01 mole per cubic decimeter. Okay. Now they want us to give a reason why equilibrium is not established. Equilibrium, guys, is not established because one important thing, guys, is not available over here. Né? And that important thing is a reversible reaction. If we do not have a reversible reaction, equilibrium is not established. Are you together? So since we don't have a reverse reaction, equilibrium will never be established. Né? Okay. Calcium carbonate solid is now added to the 2.2 grams of carbon dioxide gas in the container. After a while, equilibrium is established at 900 degrees according to the following balanced equation. Okay, the equilibrium constant for this reaction at 900 degrees is 0.0108. This is our equilibrium constant. Okay, firstly, they want us to give a reason why this reaction will only reach equilibrium in a sealed container. Because if the container is not sealed, the carbon dioxide gas will escape the reaction vessel, and then you'll simply have calcium carbonate as well as calcium oxide rather. Are we together? We wouldn't have our carbon dioxide anymore. Why? Because gas will always, guys, escape a reaction vessel. That's why we have to seal the gas. That's why we have to seal the container for us to prevent the gas from escaping. Né? Now they want us to calculate the minimum mass of calcium carbonate that must be added to the container to achieve equilibrium. They want us to find the minimum mass. Né? Okay. We were told that, guys, the Kc, the equilibrium constant is 0.01108. Né? But I know that, guys, for equilibrium constant, I need to find the concentration of products. My products are carbon dioxide. I have calcium oxide as well as calcium carbonate. These ones, guys, I'm writing in blue for a reason. Né? For us to find equilibrium constant, we need to know the concentration of our products and the concentration of our reactants. Né? We cannot find the concentration of a solid, guys. We can only find the concentration of a gas and the concentration of an aqueous solution. So if ever our substance is not a gas or aqueous solution, we do not include it. We do not include it whenever we find our Kc. So this thing over here will all be removed. So the Kc, the chemical equilibrium, is just equal to the concentration of carbon dioxide at equilibrium. So this will just be equal to 0.0108 being equal to the concentration of carbon dioxide. So therefore, I know that the equilibrium concentration of carbon dioxide will simply be equal to 0.0108 moles per cubic decimeter. Are you together? This guy simply tells me that there is a certain amount of carbon dioxide that was added to the initial amount. Are you together? Because my initial concentration was just 0.01, but now at equilibrium my concentration is 0.0108. That means there's a certain amount of concentration that was added. Né? So I can simply say that the added concentration, the concentration which was added, or rather produced by that equilibrium reaction, will simply be the concentration of carbon dioxide at equilibrium minus the initial concentration of carbon dioxide. So this will just be 0.0108 minus 0.01, and I'll end up having 0.008 moles per cubic decimeter. So this is the added concentration of my carbon dioxide. Né? Okay, but what else do I know, guys? Since the ratio of my equation is simply 1:1, that simply means that the concentration of calcium carbonate, that was used will be equal to the concentration of carbon dioxide that was produced or added. So that's just 0.008 moles per cubic decimeter. Are you together? So for me to produce 0.08 moles per cubic decimeter of carbon dioxide, I need the same amount of calcium carbonate. So now let's go and find the mass that we will need for us to find that concentration. Né? I know that concentration is mass all over molar mass multiplied by volume. Né? The relative atomic mass number for calcium carbonate, I have calcium plus carbon plus 3 of my oxygens. So this is just 40 plus 12, 3 times 16. This will simply give me 100 grams per mole. 100 grams per mole, right? So I know the concentration is 0.008. The concentration of my calcium carbonate, I want to know the mass of my calcium carbonate. The relative atomic mass number is 100. The volume of the container is 5 cubic decimeters. Therefore, the mass, I'll just cross multiply over there, and that will give me 4 grams. 0.0008, 100. That's 0.4 grams. Excuse me, let me check. Yeah, that's 0.4 grams. Okay, so the actual mass that is needed for us to form that amount of concentration of carbon dioxide is just 0.04 grams. Né? the mass of calcium carbonate 0.4 grams. Okay, let's go back, guys, and let me remind you how we got the 0.4. Né? We were told that the equilibrium constant for this particular reaction is 0.108, but I can only calculate the concentration, but I can only find the Kc if I know the concentration of my products and gases, né? Of my products and reactants. But I can only use, I can only find the concentration I can only use the concentration of aqueous solutions and gases. On my reaction, I only have one gas. The rest, they are just in solid form. I cannot find the concentration of a solid. So that's why, guys, that's why I can only use carbon dioxide, because it's the only gas that I have. Are you together? And then after finding after establishing that, I know that since Kc is the concentration of products over the concentration of reactants, I can simply conclude that the only thing that I'll use is carbon dioxide. So Kc is equal to the concentration of carbon dioxide at equilibrium. Are you together? So I did find the concentration of my carbon dioxide at equilibrium, but I realized that the concentration of my carbon dioxide is more than the concentration that I had initially. That means carbon dioxide was added. Carbon dioxide was produced. Are you together? So for me to produce carbon dioxide, I must use calcium carbonate. Are you together, guys? For me to produce carbon dioxide, that means I must use calcium carbonate. So over here, I did find the amount of concentration of the calcium carbonate that was used. Since the ratio is just 1:1, I know that the concentration that was added is equal to the concentration that was used. After finding the concentration that was used, I can simply calculate the mass that was actually used, the minimum mass. I only need a minimum of 0.4 grams for me to produce this amount of carbon dioxide. That's how, guys, I got to my answer. Né? Okay, and then now I'm told that how will each of the following changes affect the amount of carbon dioxide? Write down only increase, decrease, or remain the same. Increase, decrease, or remain the same. Né? They've added more of our calcium carbonate. If this substance, guys, was of a gas form or an aqueous solution form, it was going to have an effect, né? Are you together? Because factors that affect equilibrium, guys, one of them is concentration. Since we cannot find the concentration of a solid, that means it doesn't matter how much of calcium carbonate we add, this will never affect the production of carbon dioxide. Are you together? Okay, and then now when pressure is increased, pressure is a factor that affects a chemical equilibrium. Are you together? And whenever pressure is increased, guys, our reaction our chemical reaction or the system at equilibrium will favor the reaction, will favor the side right with the least number of gas moles. I only have one gas on my right hand side, but I don't have any gases on my left hand side. So this means I will favor the side with the least number of gas moles. If that's the case, that means the reverse reaction will be favored, and hence carbon dioxide will be used up for me to favor the reverse reaction. So carbon dioxide will decrease over here. Carbon dioxide will decrease, and then now it is found that at equilibrium, it is found that the equilibrium constant for the reaction is 2.6 times 10 to the power negative 6 at 727 degrees. Is the reaction exothermic or endothermic? Fully explain your answer. Okay. An increase in temperature, guys, né? will increase the Kc value if and only if the reaction is endothermic. Are you together? Or rather, if the forward reaction is endothermic, né? But if the reaction is exothermic, an increase in temperature will decrease the Kc value. Are you together? But now, guys, our temperature is decreased and our Kc is also decreased. Please note that, guys, the relationship between the changes in temperature of an endothermic reaction, they are directly proportional. If I increase temperature on my endothermic reaction, I will increase the Kc value. If I decrease temperature in an endothermic reaction, I will decrease my Kc value. Okay. Now let's explain. At a lower temperature, the Kc value decreased, guys. Né? Please note that this number is way smaller than 0.018. Is way smaller than that number which was given to us initially. Are you together, guys? So please note that, okay, over here, okay, we can see that at a lower temperature the Kc value decreased. Né? And I know that a decrease in temperature will always favor an exothermic reaction. This means the reverse reaction was favored. Are you together? The reverse reaction is the one which is exothermic. Why? Because if I decrease my Kc, that means I'm using my products. Are you together? So the reverse reaction is exothermic, and hence the forward reaction is endothermic. Are you together? Let us explain again. The answer will be endothermic, né? And then the explanation behind will simply be, at a lower temperature the Kc value decreases. Are you together? And in this case, since the Kc value decreased, that means the products were used. And if products are used, that means the reverse reaction was favored. And always the time, guys, please note, a decrease in temperature will always favor the exothermic reaction. If the reverse reaction is favored, that means the reverse reaction is exothermic, and hence the forward reaction is endothermic. That's how, guys, I arrived at the answer over there. Just stay tuned, guys, and wait for more videos. Thank you for your time.